Okay, so function parity. All right, we want to show if this is either even or odd or neither. So what we do is we say, let's plug in negative x. Okay, let's remind ourselves the definition of even or odd. Okay, so even, that means that if we plug in negative x, we should get the same output as if we plug in x. Okay, so when we plug in x, our output is 2x cubed minus 3x over 4x to the fifth plus 7x. Okay, that is our output. So if this is even and we plug in negative x, we should get that as our output. Definition of odd is that if we plug in f of negative x, we should get the negative of the output of when we plug in x. Okay? In other words, what would happen if this were odd is we would just be multiplying this by negative 1, and that's what we should get when we plug in negative x. Okay, we want the negative of this output. So, to plug in negative x, all we have to do is wherever we see an x, we replace it with negative x. Because that is our new input, negative x cubed minus 3 times negative x over 4 times negative x to the fifth plus 7 times negative x. Sweet. Okay, so then carrying on, well, negative x cubed is negative x cubed. Negative x parentheses cubed is negative x cubed. So we get negative 2x cubed plus 3x. Okay, if you raise a negative exponent or a negative variable or a negative anything to an odd exponent, then you're going to get a sign change happening. So this was a positive 4, now it's a negative 4x to the fifth. And then this was a positive 7, so now it's going to be, or a positive 7x, so now it's going to be a negative 7x. Okay, so at first glance, it looks like this could be odd because our signs have changed. But in this case, it's not odd because if it were odd, the negative of this output is negative 1 times 2x cubed minus 3x, and that's over 4x to the fifth plus 7x, which equals negative 2x cubed plus 3x over 4x to the fifth plus 7x. Okay, so this is the negative of the output, which is not the same as what we got. Okay, because the negative of the output still has a 4x to the fifth plus 7x on bottom, and we have a negative 4x to the fifth minus 7x on bottom. So this is actually an even function in disguise because all the signs changed, which means they essentially end up undoing each other. So how we can see this, like what we want to show is that this is actually algebraically equivalent to our original, this. They're the same, even though all their signs are different, because if we factor out a negative, we get negative 1 times 2x cubed minus 3x over negative 1 times 4x to the fifth plus 7x. We have a negative 1 on top. We have a negative 1 on bottom. So that means that they cancel. And we are just left with 2x cubed minus 3x over 4x to the fifth plus 7x, which is exactly what we started with. So this guy is even. Boom. Okay, so a good thing to do is to maybe always see if you can factor out a negative from the top and the bottom. If your function doesn't look like it's either even or odd, that's a good way you can algebraically maneuver it to see if it actually is even or odd, just in disguise. Okay, and if you factor out a negative and it doesn't fit the definition of either even or odd, then that means it's neither. Okay, but in this case, even.